Okay, guys, now we're going to look at concept number 6, which is applying conversion factors to determine the number of atoms or ions in a known mass of a compound. For this, what you need to understand is that to determine the number of atoms or ions in a compound, you will need conversion factors that are ratios of the number of atoms or ions in the compound to 1 mole of the compound. What does that mean? Basically, you're going to need to know how many different atoms or ions, if it's an ionic compound, are in 1 mole. So you're going to have to look at the formula for these compounds. Let's look at an example problem. Example problem number 1. It says a sample of aluminum chloride has a mass of 36.6 grams. And I want you to figure out how many aluminum ions are present and how many chloride ions are present. In order to do this, the first thing you need to do is you're going to need to determine what the molar mass of aluminum chloride is. So we've done this before, so let's go through this. This should take very quickly. So you need to determine what are the two elements in aluminum chloride. So we have aluminum and chlorine. You're going to need the masses of those elements. So you're going to need your periodic table. So in the formula of aluminum chloride, we have one aluminum atom with the mass of 26.98 grams that we got off our periodic table. So when we multiply that together, we get 26.98 grams. For chlorine, however, there are 3 chlorine atoms in aluminum chloride because of that little 3. And the mass of aluminum chloride from our periodic table is 35.45 grams. So when we multiply those two numbers together, we get 106.35 grams of chloride. Now what we need to do is determine the molar mass. So remember, we need to add these two values together. So 26.98 grams plus 106.35 grams. And we plug that into our calculator, we get 133.33 grams per mole of aluminum chloride. That is the molar mass. Once you have the molar mass, then you can continue on with the problem and actually solve it. But for these types of problems, you need to get the molar mass of the compound first. So anytime we're looking at ions that are present or atoms that are present, we need to get to moles. So how do we go from mass of aluminum chloride to moles of aluminum chloride? We need to determine the molar mass. So that's why we had to solve it first. So now we got to go back to the problem. We were given a sample of 36.6 grams. So we're going to convert that 36.6 grams of aluminum chloride to moles of aluminum chloride. And by doing that, we're going to use the molar mass, which is 133.33 grams of aluminum chloride per that 1 mole. Remember, grams, the 133.33 grams needs to go on the bottom, so our units will cancel. When we plug that into our calculator, we get 0.267 moles of aluminum chloride. Since we now have moles of aluminum chloride, we can use that number to determine how many ions are present. So let's look at how that's done. So first we got to convert from moles of aluminum chloride to molecules of aluminum chloride. So we're going to have to use Avogadro's number. So we start with 0.26 moles of aluminum chloride, and then we have to get moles of aluminum chloride to cancel, so they have to go on the bottom. Avogadro's number needs to go on the top. Moles of aluminum chloride will cancel, and we'll be left with 1.61 times 10 to the 23rd molecules of aluminum chloride. Now that we have molecules, now we could talk about actual particles that are in that molecule. So now what we're going to do is we're going to calculate the number of aluminum and chloride ions. So how do we do that? Let's look at aluminum ions first. So we take 1.61 times 10 to the 23rd molecules of aluminum chloride, and in those molecules we know that for every 1 molecule of aluminum chloride you have 1 aluminum ion. When you multiply that through after we cancel out our units, we get that there are 1.61 times 10 to the 23rd aluminum ions. You have to do the same thing. We are using the same number for 1.61 times 10 to the 23rd molecules of aluminum chloride. And now we're going to calculate the number of chloride ions. Now this is going to be a little bit different because when we look at our formula, aluminum chloride has 3 chloride ions for every 1 molecule of aluminum chloride. So we're going to take that and we're going to cancel out our units like we always do, so that we know that we are actually now solving for chloride ions, and we get 4.83 times 10 to the 23rd chloride ions. Now I know this might be a little bit confusing. Stop, rewind, go back if you need to, but take a serious look at the example problems that are in your packet, because I promise those will help you.